Welcome everybody to another extension day 5.4b. Normally these B extensions are shorter, but today we're kind of cramming a lot of information in. However, all this information should be pretty easily digested just because, it's just kind of like weird little cool add-ons to things that we already know. And the first little add-on and cool piece that we're going to be looking at is called a piecewise function. And a piecewise function is defined by two or more equations. Each, quote unquote, piece of the function applies to a different part of its domain. So let's put this into words that we might more easily understand with, looking at this. It's a function, right, y or f of x, that is defined by two different equations. I have one equation here and I have one equation here. So depending on the domain, so for example, the top part says when x is less than or equal to 0. So that means that for all the values that are less than or equal to 0, that's everything over here, the function looks like x minus 2, right? This line right here. But then at that point, it changes. And when x is greater than 0, right here, it changes and it looks like 2x plus 1 instead. So we get these cool situations where it doesn't have to be one singular line throughout the entire graph, but instead it can be one function that's defined by a certain type of graph till one point, and then it switches and it turns to a different function at a different point. So it's a really cool idea, and we'll just look at how we graph something like that in this first example. Okay, so I'm going to do it in, let's say, blue. I'm going to use blue. The first one says that the function should look like negative x minus 4 for x values less than 0. So all the way up until 0, it should look like this function. So what does that function look like? It looks like a y-intercept of negative 4. 1, 2, 3, and 4. And then it also looks like a negative 1 slope. So that means it should be looking like this. Da, 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 da. Cool. And draw a nice line through that. Trying to make it as straight as possible. Just like that. Now what's the other function look like? I'll draw that one. I'll still do it in blue because it's technically the same function. The other function is y equals x. Easy. That's a very, very easy one. Y-intercept of 0. Slope of 1. All the way up. The way up. Now, notice I did not pay attention to the domain there at all yet. What I'm going to do now is kind of just take off the pieces that I don't care about. I'm going to use my eraser, and I come over here, and the first part says that it should look like this negative x minus 4 function all the way for values that are less than 0. So any values greater than 0, x values, so x values like 1 or 2 or 3, I shouldn't see this function at all. And even so, it shouldn't even be when it equals 0. So I shouldn't have that there. I should have a nice open circle that says it goes up to that point, but it doesn't actually reach that point. Now it also says that it should be y equals x, the second function, for x values that are greater than or equal to 0, but no x values that are less than 0. So here x is negative 1, negative 2, negative 3, so I shouldn't see this function on this side of the equation. So this one should go away. Here we go. And now I have my piecewise function perfectly written. And let's just recap it. On the left side, x values that are less than 0, I see it appearing like this function right here, negative x minus 4. And it goes to the y-intercept of negative 4, but it doesn't touch it because it doesn't exist at 0. At 0, it jumps up to this one. And it turns into the function y equals x. And it continues up and up and up. It's kind of a weird thing to grasp at first, but it's really, really cool once you get a hang of it. Let's go to our next example, which is just going to be going in the opposite direction. Instead of graphing the piecewise function, I want to actually try and write one. Okay, so the first thing that I need to do is call the function. It's a function that's going to use x's, and I put a little bracket. The bracket tells me whatever comes inside of here is part of this one function. So now I need to figure out what my two different functions are. What is this function right here? And what is this function over here? Okay, so let's look at this one. It has a y-intercept of 3, and it has a slope of 1 over 1. Looks like it's going one box for every one box. So this is going to be f of x equals x, and the y-intercept is 3 plus 3. So a slope of 1 and a y-intercept of 3. Cool. Now what's the other one? It has a y-intercept of negative 1, and it looks like it has a slope of up 2 over 1, up 2 over 1. So that's 2x, and then this y-intercept again was negative 1. Now let's focus on this domain stuff, okay? This function looks like it's this top one, the one that we wrote first, all the way up until 0. But it's an open circle on 0, which means it doesn't include it. So I put a comma, and I say that it's for x values that are less than 0. But it doesn't include 0, so I don't say it's equal to. Now for the bottom one, it looks like it starts at 0, and it includes it because it's a closed circle. And then it goes up and it up and it up, and it continues with that function. So it's x values that are greater than or equal to 0. See, or equal to because it's a closed-in circle. And that's it. Simple as pie. Now let's look over at a step function. A step function is a form of a piecewise function, but it's just a little bit different. And what it is defined by constant values. So not particular functions, but constant values, like horizontal lines over the domain. And the graph of a step function consists of a series of line segments, or just lines. So it's a whole bunch of these different pieces, but they're simpler pieces broken up into more intervals. Okay, so we see the domain, the x values, are split up a lot more in this one. In the last ones, we only had it split into 2 pieces. This is split into 5 different pieces. But it's not split into pieces for different functions. It's split into pieces for just singular values. So let's just put in some x's here. This is going to be x equals 1. This will be 2, 3, 4, and 5. And then let's put over here, let's say 5, 50, 75, 100, 125, and 150. Wow, that was perfect. And now let's go and let's graph it. I'm going to put it in red so we get some color in here. So what this tells me is from 0 to 1, my cost is 50. So from 0 to 1, I'm going to be doing a horizontal line, a straight line at 50. 0 to 1, and it includes 1. This thing says or equal to, so that's a solid point on the 1. So that's what that looks like. It's basically the line y equals 50. It's a horizontal line right there. And then it tells me that at 1, all the way to including 2, so it doesn't include 1, but it goes all the way and includes 2, it's equal to 75. So right here we jump up. We have an open circle because it does not include 1. It's going to be 75 all the way until 2, and it does include 2. Then I do the same thing. I jump up again to 100, and it doesn't include 2, open circle, all the way till 3, closed circle, because it does include 3. And then I jump up again, open circle, line, closed circle, jump up again, open circle, line, closed circle, and I'm done. This is a step function, and it's very, very well named, obviously, because it looks like you're stepping upstairs. Right? Those are really, really, really cool ones. And once you get the hang of looking at this chart and being able to understand the domains and calculating it, it'll be very, very easy for you. Now let's look at our last little extension type thing we're doing today, and that's absolute value functions. Alrighty? An absolute value function has a V-shaped graph. That opens either up or down. And we need to remember that an absolute value of a number is always positive. So when I look at a graph of an absolute value function, it makes sense, right? That if I have the function y equals x, it would have a slope of 1, and it would have a y-intercept of 0, but y equals x would normally come down here into the negatives. But since the absolute value never becomes negative, it kind of gets rebounded and goes bing, back up. And it continues to go back positive. So that's how we're going to kind of graph these things. We're going to worry about what the function would look like without the absolute value, and then kind of take away all of the negative and rebound it in a way. So let's take a look at this first one. We're also going to be using the ideas that we talked about last time with translations, which are really going to help us in graphing these functions. So I'm going to graph in blue the new functions. The old function, the y equals the absolute value of x, is already written right here in red. So this is y equals the absolute value of x, whereas the one that I'm going to be doing is this one right here in blue. So what does it mean to have this constant at the end here? We talked about that last time. It is a vertical shift of 3. So if this was just the function y equals x plus 3, it would have a y-intercept of 3, 1, 2, 3, and then it would have a slope of 1. So it would look like that. And it would go on forever and ever and ever in that direction. But it would also go on and on and on forever in this direction. But what's the problem with that? The problem is that then I would be getting negative numbers. So it needs to rebound in the opposite direction. And I still get that V-shaped graph because it's a nice absolute value function, but it's shifted upward from the original y equals absolute value of x 3 units. Cool. Now let's look at one that's slightly different, but we need to make sure that we can see a clear difference here. Now between this blue function I had plus 3, but it was on the outside of the absolute value. Make sure that we take very, very close note of this. The plus 3 was on the outside of the absolute value, so it shifted it up. This one has minus 2, but it's on the inside of the absolute value. And what that's going to do is shift it either right or left. Okay? So when I have something on the inside of the absolute value, it's going to shift it right or left. Now this says minus 2. Minus 2 means I'm actually going to be shifting 2 to the right. So my v starts over here, still with the exact same slope of 1, but 2 units over to the right. That's what the minus 2 does. And it might seem a little bit weird, like counterintuitive, that minus 2, you might think it means go to the left, but it does in fact mean going to the right. Now let's look at one more type of change that happens with the absolute value function, and that's when I have a number multiplying it. What do you think a number multiplying on the outside is going to do? This kind of looks like y equals mx plus b when there's, plus and then there's nothing there. So this number that's right out in front here, what does the m normally stand for? It normally stands for slope. So why shouldn't this stand for slope? It is. The negative 1/2 that's multiplying the absolute value of x just tells me what the slope should be, right? And it actually turns the entire absolute value function negative. Even though the absolute value can never be a negative number, I have a negative on the outside of the absolute value itself. So let's say I try a number or two. X, y, let's say I put in a 1 into this equation. Absolute value of 1 is 1 times negative 1/2. That's negative 1/2. What if I put a 2 in? 2, absolute value of 2 is 2 times negative 1/2. Well, that's negative 1. So I'm getting negative numbers in my output simply because the negative sign is on the outside of the absolute value. So it kind of cheats the system a little bit there. So let's look at how we would graph this. I could think of 1/2, the slope negative 1/2, which is going to be, over 2 and down 1, over 2 and down 1, over 2 and down 1, and I make that. And then I think of the slope in this direction, over 2 and down 1, over 2 and down 1, over 2 and down 1. 2, 2, 2, 4. Cool. So, how did that happen? How did I get it into these two quadrants instead of up here like all of the other ones were? Well, did you notice that all of my y values were turning out negative? Because I have the negative sign in front, that actually means that all of my values are always going to be negative. So this one is flipped, right? You kind of see a little bit of mirroring going on across. Let's see if I can highlight this. Across this line, we see mirroring happening, right? It's like a mirror image from the top to the bottom. When I have a negative sign, that's what happens. That's what it does. It flips it over that line. And then the 1/2 slope, what did that seem to do? Originally, this had a slope of 1 on the top. Down here, it has a slope of 1/2. So it actually made it look a little bit wider, a little bit fatter. So the slope is going to affect how fat or how skinny this V becomes. All right, there's a lot to take in there, and we're going to do plenty of these problems together. Do your best with the assignment that we have for tonight, and write down any questions, and we'll talk about them in class. Alrighty, fare thee well.